One other thing that I want to make sure that you know how to do is how to be able to read a graph. So if we have, or we are asking some information about anything, I may want to know, what is the maximum of a particular function. So let's say that I ask or looking at local maxes and mins, and I want to figure out what the value is. So let's take a look at the first graph that we did on video, and this is the first graph, which is this particular equation here. Notice that, of course, it's a third degree function. It has one peak and one valley, because remember, it's 3 minus 1 is the maximum number of peaks and valleys that we can have. So we can have 2, which is exactly what we have. So if I come in and I say, okay, I want to know exactly what f at, let's say, -4. So this would be -4 right here. So this would be x is equal to -4. Then we would go up and take a look at the value. So f at -4 would be, from what it looks like, 130. So f at -4. So looking at the graph, I know that f at -4 equals 130. So whatever it is that we're taking a look at data-wise, that would be one identifier. Let's say I want you to estimate where this peak is. So notice here's the peak approximately. I can kind of come down here and I can take a look. It looks like it's probably about halfway in between -5 and -6. So that means that my peak, or my local max, exists at x is equal to -5.5. So somewhere between 5 and 6 is where I'm going to estimate it. So somewhere right around here. If I go all the way up, I can see that that's where my peak is. If I'm looking for the lowest point, or the lowest local minimum, it's going to be this point right here, which looks like it's somewhere between 3 and 4. So I know that my local min exists somewhere around 3.5. So somewhere between 3 and 4. Again, we're making an estimate. I do want you to come kind of close to the estimate. So, 4 or 3 would not work, because you can see pretty obviously that it's somewhere in between, but 4.5 is fine. And so what we're doing is just really trying to identify particular points and seeing what's happening to the function during those times. So there might be questions that are asked around those that you need to make sure you can go back and you can read the graph and see exactly what it is that it is supposed to be doing. So remember that you are just sketching the graph. You are not actually going in and graphing it. Specifically, you're sketching it as opposed to graphing it. Graphing it would be, more exact. We have to figure out what these numbers are and then really make a good determination. A sketch is just to draw it so that we can get a general idea of what the graph is going to look like. So you always want to have a general idea of what they look like whenever we're dealing with all of these different values, and be able to make some predictions or some information about those. Notice, of course, that where it crosses 0, whatever the y value is, that's where it's going to be. We can see what the y-intercept is when we're looking at these kinds of things. So we've got a lot of information based on just what the graph is going to look like, and that we can pull up specifically to answer any questions that we do have.